What's going on, everyone? Patrick here, welcome back. And in this next question, we have to solve for x in these proportions here. So starting with number one, we got 5 to the x is equal to 60 to the 36. So we have equivalent ratios. We have to solve what this x would be. The way I like to personally do it is just put these as fractions like that. And then you can just solve for x from here. You can cross multiply. Another thing you can do actually before cross multiplying is if you have a fraction that can simplify. So notice that the 60 we could divide by 12, and we could divide the 36 by 12, and we end up getting 5 over 3. And then actually from here it's easy to see that x is equal to 3 because the numerators are the same. So that's another way you can go about it. But if you just cross multiplied, so if you did 60x equals 5 times 36, then divided both sides by 60, when you do this calculation, you'd also get x is equal to 3. So multiple ways you can go about it, but the answer to number one is x is equal to 3. Now, with number two, we got x over 3 is equal to 15 over 12. And then from here, notice that we can divide this by 3, divide this by 3. So we'll have x over 3 is equal to 5 over 4. So unlike number one, we still can't tell what x would be because the denominators here are different versus before the numerators were the same. So you could see what the denominators would have to be. It was easy to get the x value, but here we're still going to have to cross multiply even after simplifying the fraction. So we'll have 4x equals 15, divide both sides by 4, and so x would end up being 15 over 4. So that would be the answer. 15 over 4 doesn't simplify any further, and if you want to have that maybe as a mixed fraction, it would be 3. 4 goes into 15 3 times. 4 times 3 is 12. 15 minus 12 is 3. There's a remainder of 3 there. So 3 3/4 is another way to write it. Right? So either of those is the answer to number 2. Then number 3, notice how number 3 and 4, the ratios have fractions within them. But same methodology applies, so what we would do is we would just put a fraction within another fraction like that. So this ratio we could represent like this, then we'd have x over 4 over 5, like that. Then from here, same thing. So we'd multiply, cross multiply, so we'd have 4 over 5 times 6 over 7, and then we'd have 10 over 9 times x, like that. And so multiplying these out, we'd end up with 24 over 35 equals 10 over 9 x. And then to isolate for the x, we could divide by 10 over 9. We could divide both sides by 10 over 9. So we'd end up with 24 over 35 divided by 10 over 9. And that would be x, like that. And so from here, 24 over 35 times 9 over 10. Right, we flip the fraction and multiply it now. And then we can multiply the denominator, the numerators. Notice we could simplify here a bit. So notice that 24 over 10, that could simplify to 12 over 5. And now we can multiply from here. That's what I would recommend doing. So this would end up being, so this would be 175 at the bottom. Right, 5 times 35 is 175, and then 12 times 9 would give us 108. Then 108 over 175, that doesn't simplify any further. Right, so that would be the answer to number 3. And then finally, number 4, we'd end up having x over 4 over 7 equals 2 over 3 over 8 over 21, like that. So from here we could cross multiply, 4 over 7 times 2 over 3. And then let's combine these into one fraction. So this would be 8 over 21. And actually, it's the same fraction. So look what happens here. Divide both sides by 8 over 21. What's 8 over 21 divided by 8 over 21? Well, something divided by that same thing will always give us 1. So that's the answer to number 4. X is equal to 1. So with number 3, we got a fraction answer, but just because there's fractions in the ratios doesn't mean that the final answer is always going to be a fraction. Sometimes you can get a whole number like that.